Good afternoon. The very last thing we need to talk about in Chapter 6 is your different electron configurations. There are 4 different kinds of electron configurations, and so I'm going to briefly go over those now. The first kind of electron configuration we're going to start with is the full electron configuration. And what you've got to remember about electron configuration is when you're asked to give an electron configuration, you're being asked to show me how the electrons are arranged in that particular atom. So for a full configuration, you have to start at the first element on the periodic table, which we know is hydrogen. All right, and so every time you enter a new row or a new block on the periodic table, you're going to have to give me a new big number and a new letter. And so let's say if we chose the element carbon on the periodic table, carbon is element number 6. And so I know I have to start with the first element, which is hydrogen. And hydrogen starts on row 1 in the S block. All right. And so hydrogen and helium would be my 1s. And then I've got to have an exponent that tells me how many electrons are in that particular row and that particular sublevel. How many electrons are there? All right, and so we've used 2 of our electrons. We've got 4 more electrons to go. And so after atomic number 2, which is the atomic number for helium, comes atomic number 3. If you look at where atomic number 3 is, you notice that atomic number 3 starts on row 2. It starts in the S block. And column 1 and column 2 on the periodic table represent my S block. And so I know the element carbon is past column 1 and 2. So when I look at my configuration, I'm going to have a 2 as the exponent because, again, when I get 2 electrons in the S sublevel, then that sublevel is full. After atomic number 4, which is the atomic number for beryllium, comes atomic number 5. If you notice where atomic number 5 is, you notice it's still on row 2, but now instead of it being in the S block, it's located in the P block. All right? And so when I look at where carbon is actually the second element in the P block on row 2. And so my configuration for carbon would be 1s2, 2s2, 2p2. Now, if you add these exponents together, you should end up with the atomic number for the element that you were trying to do. All right? So if we were to choose another element, let's say we chose calcium, we're going to do the same thing. And so we're going to list every row and every block of the periodic table we come to. And so we start with hydrogen and we move on to calcium. Calcium has 20 as its atomic number, so I've got to include all 20 of those electrons. So I've got to start with 1s. I know the maximum I can have if I'm an S is 2. After element 2 comes element number 3, which is located in the 2s block of the periodic table. Again, the maximum number I can have as an S is 2. So after atomic number 4 comes atomic number 5, which is located in the 2p block of the periodic table. When I count over from 5 to element 10, that gives me a grand total of 6. The maximum number of electrons I can have if I'm a p is 6. So after atomic number 10 comes atomic number 11, which starts on row 3, back in the S block. My maximum number for row 3 in the S block is 2. After I go to atomic number 12, after 12 comes 13. 13 is located on row 3 in the P block. If I count over, I'm counting over to element number 18, which is argon. After 18 comes 19. Element 19 is on row 4. It's located in the S block. And so if I'm only going to calcium, then Element 19 is my 4s1, element 20 would be my 4s2. So when you have a full configuration, again, you have to show me everything from the element hydrogen to the element that I asked you about. The next kind of electron configuration you can have is an abbreviated or a condensed electron configuration. It's sometimes called the noble gas configuration. This configuration is a little different because instead of writing all of this out, you would be able to shorten it and give me the configuration. So if we choose the same two elements we had before, if I were doing the abbreviated or condensed or noble gas configuration for carbon, what I would do is I find carbon on the periodic table and I go back to the last noble gas I passed before I got to carbon. So carbon's on row 2, so the last noble gas I passed is on at the end of row 1. Because remember, my noble gases are in column 18 on the periodic table. And so what I would do to write this abbreviated configuration, I place that noble gas in brackets. And what that does is that covers everything from hydrogen up to that noble gas. And then the only thing I have to list is what comes after this noble gas. So helium's at the end of row 1, so I've got to list everything from row 2 onward. And so I would do that the same way that we did with the full configuration. After helium is atomic number 3, which is located on row 2 in the S block. And then I move to row 2 in the P block. And I have my abbreviated configuration for carbon. Now, if we do the same thing for calcium, we know that calcium is on row 4. So I've got to figure out what noble gas is at the end of row 3. When I look at the periodic table at the end of row 3, that last noble gas before I get to calcium is argon. And so I put argon in brackets. Again, that covers everything from hydrogen up to argon. So I just have to list everything that comes after argon. So argon's at the end of row 3. So I need to start on row 4. And so I would list my 4s2. All right, so these are 2 of your 4 electron configurations. The third electron configuration type that you can have is your electron dot structure. Your electron dot structure. Now, for your electron dot structure, what you do is you would write the symbol for your element, and so we're going to use carbon again. I write the symbol for my element. I know that carbon is in column 14 or column 4A. Now, please remember, when you are given the AB numbers, the A numbers, the number that comes in front of the A tells you how many valence electrons there are in that particular element. So if we're looking at carbon and it comes in 4A, that means that there are 4 valence electrons in carbon. Now, when I say valence, please remember that means how many electrons there are in the outermost energy level. And actually, if you look at the full configuration for carbon, you will see that there are 4 valence electrons there. Because you'll notice the highest energy level we have is energy level 2, and that's represented by our big number. And if I count how many electrons are on energy level 2, notice I've got 2 in the S and I've got 2 in the P for a grand total of 4 valence electrons. So I've got my 4 valence electrons, and so for my electron dot structure, I've got my symbol. Around my symbol, I place the number of dots that represents how many valence electrons I have. Please remember, for these electron dot diagrams, you have to have 1 dot on each side before you put 2 dots on any side. And so if we do the same thing for our calcium, the symbol that represents calcium is my Ca. And if I notice my highest energy level for calcium is 4, how many electrons do I have in the 4th energy level? There are only 2. And so when I draw the structure for calcium, I need to have 2 dots. And now you'll notice calcium has 4 sides. It does not matter what sides I put the 2 dots on, as long as I put 1 dot on each side before I start putting 2 dots on any side. All right, so if it's an A group, the number that comes in front of the A will tell you how many valence electrons it has. And you just place those valence electrons around the symbol for the atom, and that gives you your electron dot structure. If it is a B group, though, you cannot use that same rule. If it's a B group, it's usually easiest to look at either the full or abbreviated configuration, and from the full or abbreviated configuration, then you can determine what's the highest energy level and how many electrons there are in that highest energy level. Now, that takes care of those first 3 kinds of electron configuration. That takes care of those first 3 kinds of electron configuration. Normally, students are able to do those first 2 fairly well. It gets a little more complicated once we get past element 20 on the periodic table. But I can do some examples where we do some bigger atoms in just a moment. But I do want to take a moment to make sure that you know the 4th kind of electron configuration, which is your orbital diagram. And so you will have some of these kinds of problems on your homework. When you're looking at the orbital diagram, there's some things that you need to know about your orbital diagrams. So generally with the orbital diagram, it's easiest to start with a full electron configuration because you need to know how many orbitals you need to draw for each one of your particular sublevels. So please remember, if it's an S, then you only draw 1 orbital. If it's a P, you would draw 3 orbitals. If it's a D, you draw 5 orbitals. And if it's an F, you draw 7. So let me choose the element iron. Let me choose the element iron. And I'm going to write out the full electron configuration for iron. So if I start with hydrogen, and I just move my way across the periodic table looking at the atomic numbers until I get to the atomic number for iron. All right? Now, iron's on row 4. We did up to calcium, so we know we're at 4s2. And this is where students get off just a little bit. If you look on row 3, you should have 3 sublevels for row 3. But if you look at the periodic table, you actually only see 2 blocks on row 3. And that's because that 3rd sublevel is actually on row 4. So after your 4s2, you're going to introduce your D sublevel. But even though it's on row 4, it gets the number of 3. Okay, so every time you go to the D block, you have to go down 1 from your row number to have it written correctly. All right, and so when I go into the 3D block of the periodic table, all I'm going to do now is count over till I get to the element iron. And when I do that, 1, 2, 3, 4, 5, 6. All right, and so my configuration for iron would be this, my full configuration. Now, this helps me because now I can draw my orbital diagram for this. So everywhere that I have an S, I'm only going to draw 1 orbital. And you can generally draw your orbitals as boxes or circles, but you do need to make sure you have labeled those. All right, so everywhere I see an S, I'm going to draw 1 box and I'm going to label it. So I've got 1s, I've got 2s. Then when I come to my P, I need 3 boxes. So I've got my 2p. On my 3s, I need 1 box. On my 3p, I need 3 boxes. All right, on my 4s, I need 1 box. And on my 3D, I need 5 boxes. All right, now, biggest thing with electron configurations, please remember when we write these according to increasing energy. And so, because they are written according to increasing energy, that's why 4S comes before 3D. Because 4S actually has less energy than 3D does. All right? And so, once I have my boxes, I use arrows to tell how many electrons are in that particular sublevel. Remember, no more than 2 electrons can live in any particular orbital. And so when we show our electrons, we show them as arrows, and they have to be doing different things. So I need to have, because there are 2, I need to have 1 arrow going up and 1 arrow going down. And then when I go to my 2S, because I started with up in the 1S, I need to have that one going up and then another one going down. And again, remember, I'm increasing in energy every time I go to a new one. But now when I get to the 2P, please notice that those 3 orbitals are at the same energy. And so, just like people, if electrons have the choice, they're going to go into orbitals that are at the same energy one by one. So we want to fill each one, or we want to put at least 1 electron in each orbital before we start putting 2 in any orbital. All right? All right, and so that takes care of my 2p, and notice I've got my 6 electrons in there. When I move on to my 3s, I'm going to do the same thing. First arrow going up, second arrow going down. When I move to my 3p, again, I need to fill them up, or I need to have 1 electron in each before I start filling them up. All right, and when I move to my 4s, 1 going up, 1 going down. When I move to my 3D, now notice I've got 6 electrons, but I only have 5 boxes. So I'm going to have 1 going up, 1 going up, 1 going up, 1 going up, and 1 going up. That takes care of 5 of those electrons. I need a 6th one. So for the 6th one, I'll have that electron going downward. All right. So now you've got examples of your 4 different kinds of electron configurations. Please again remember they are arranged according to energy. We do not put them in numerical order. If I don't tell you which kind of electron configuration to show, you can show whichever kind of electron configuration you would like. However, on your homework, I'm telling you specifically which electron configurations I want to see. So please make sure you remember that. Please remember how many orbitals you need. And so if we consider our orbitals, if we know that 1 orbital can only hold 2 electrons, then you also know how many the maximum number of electrons is for each orbital. So remember, if it's an S, that maximum number of electrons is going to be 2 because there's only 1 orbital. If I'm a P, the maximum number of electrons I can have is 6. If I'm a D, the maximum I can have is 10. And if I'm an F, that maximum is 14. So when you write your configurations as you're going through, make sure you check these numbers over your letters. Those exponents, if it's an S, you can't have any more than 2. You can't have any more than 6 on a P, 10 on a D, or 14 on an F. Now, let's do a configuration for a very large atom. And the atom that I'm going to choose, let's say I choose the element number 72, hafnium. All right, the symbol for hafnium is HF. All right, and so we notice that HF has actually 72 electrons. So I've got to start at element 1 on the periodic table and go all the way to element 72. So if you've got any questions on how I got this configuration, please let me know. As I'm starting, I noticed that the element hafnium is on row 6. So I know when I get to a big number of 6 that I'm getting close to the end. All right. And I know that it's in the D block, so I know when I get to 5D, then I'm definitely at the end. Now, generally the mistake that students make is they forget that 4F block because of the 2 rows that are pulled out at the bottom. And so once I get to my row 6, I know I'm close to the end. I've got to include my 4F. And then when I come back up to the 5D block, I just count over to hafnium, which is the second one. So that would be 5D2. Now, there are a few exceptions to the filling order, but you'll notice that for all the problems we've done so far, we had to fill up that sublevel before I can move on to the next one. So you have to have these at maximums before you can move on to the next one. But there are exceptions to that filling order. And those exceptions occur for the elements in column 6 and column 12. And the reason those are exceptions is because with these, they generally steal, so they won't have a full subshell. So if we pick an element in column 6, let's say chromium, when I do the configuration for chromium, I see that chromium's on row 4. It's in the D block, so it's going to be on 3D. So when I get to 3D in my configuration, I will know that I'm where I need to be. 4S. Now, you would think that the configuration for chromium is this. But what we actually find is that elements are much more stable when they have either a completely filled subshell or a half-filled subshell. And so what this element does, and these that are in column 6, they all do this, they actually steal one from the S so that your S ends up with only 1 electron, which makes it half full, so that my D can also get half full. So the one that I take from that S, it actually goes to my D block so that it's half full. And so the elements in column 6, they steal from that S so that they can get their D block half full. The ones in column 12, they steal from the S so that they can get their D block completely full. So all of those elements that are in column 6 and column 12, they follow these exceptions to the filling order. So make sure that you remember that as you're completing your homework. If you've got any questions on anything, let me know. I know this was a lot, but reach out if you need any assistance. That's what I'm here for. I hope you have a good rest of your day, and I hope this chapter does not become too much of a challenge for you. There is a lot of math that's mentioned in this chapter, but I'm really just concerned with you being able to write electron configurations. So you definitely need to know how to write electron configurations. You definitely need to know how to do the energy and wavelength and frequency conversions that were taught about in video 1. If you need any help with any of this, just let me know. I hope you have a good rest of your day.